So, hi guys, I'm back again for my another vlog. It is the summary of the chapter 7 IP addressing. So, I will discuss to you the introduction of the IP addressing. The addressing is a critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 or IPv4 and Internet Protocol version 6 or IPv6 provide hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. So, this chapter examines in detail the structure of IP addressing and their application for the construction and testing of IP networks and subnetworks. So, IP addressing. The objectives and sections of this chapter is to explain the use of IPv4 addresses to provide connectivity in small to medium size business networks, convert between binary and decimal numbering systems, describe the structure of an IPv4 address including the network. It describes the structure of an IPv4 address, including the network portion, the host portion, and the subnet mask. Compare the characteristics and uses of the unicast, broadcast, and multicast IPv4 addresses, and then explain public, private, and reserved IPv4 addresses. So, the 7.2 IPv6 network addresses configure IPv6 addresses to provide connectivity in small to medium-sized business networks. Explain the need for IPv6 addressing. Describe the representation of IPv6 address. Compare types of IPv6 network addresses, configure global unicast addresses, and describe multicast addresses. So, the 7.3 connectivity verification, use common testing utilities to verify and test network connectivity. Explain how ICMP is used to test network connectivity. And lastly, use ping and traceroute utilities to test network connectivity. So here we go to the converting. So let's do the conversion. This is the conversion of binary to decimal conversion. So this is the line of the value, positional value, then the binary number, then calculate, add them up, and then the result. So the dotted decimal notation is here. So this is the binary number. Then to convert a binary IPv4 address to decimal, enter the 8-bit binary number of each octet under the positional value of row 1 and then calculate to produce the decimal. So here is the decimal to binary conversion. It's always add 0, then add 1. Then to convert a decimal IPv4 addresses to binary, use the positional chart and check first if the number is greater than the 128 bit. If number A is 0, is placed in the position. If yes, then A1 is placed in the disposition. 128 is subtracted from the original number and the remainder is then checked against the position 64. If it is less than 64, A0 is placed in this position. If it is greater, A1 is placed in the position and 64 is subtracted. The positional repeats until all positional values have been entered. So this is the examples of the decimal to binary conversion. Then the prefix length. The prefix length shorthand method of expressing the subnet mask. So this is the subnet mask, then the 32-bit addresses, then lastly the prefix length. So it is equals the number of bits in the subnet mask set 1, then written in slash notation followed by the number of network bits. So the IPv4 communication. It is the unicast is one-to-one communication. Then the broadcast is one-to-all. Is the example 1. This is the computer that send message. It is received by one only. Then the broadcast is the one that one message sent but received by all of the computers or communications. Then the multicast is one to select group. The message will be delivered in the selected group. So unicast is one-to-one communication. Use the address of the destination device as the destination addresses. So the broadcast transmission is message sent to everyone in the LAN. Destination IPv4 address has all one in the host position. Then the multicast transmission is addresses reserved for multicast. Routing protocols use multicast transmission to exchange routing information. So let's go to 7.2, the IPv6 network addresses. It is the IPv6 versus IPv4. The IPv6 has a larger bit or has the 128-bit address space, 340 undecillion addresses, solves limitation with IPv4, adds enhancement like address auto-configuration. Why IPv6 is needed? Rapidly increasing internet population, depletion of IPv4, issues with NAT, Internet of Things. The IPv6 address representation. It has 28 bits in length, every 4 bits is represented by a single hexadecimal digit. Hectet, an official term referring to a segment of 16 bits or 4 hexadecimal values. So it is the IPv6 addressing representation. Then the meaning of unicast in IPv6 are, let's say, the three types of IPv6 addresses: unicast, single source IPv6 address; multicast, an IPv6 multicast address in use to send a single IPv6 packet to multiple destinations; and lastly, the Anycast. An IPv6 Anycast address is any IPv6 unicast address that can be assigned to multiple devices. Then the unicast addresses: the global unicast, the link local, and the unique local. So the trace route or testing the path is a utility that generates a list of hops that were successfully reached along the path. Round trip time, or the RTT time, is it takes the packet to reach the remote host and for the response from the host to return. Asterisk is used to indicate a lost packet. So, the chapter 7, the conclusion, is to explain the use of IPv4 addresses to provide connectivity in small to medium-sized business networks. Configure IPv6 to provide connectivity in small to medium-sized business networks. And lastly, use common testing utilities to verify the test network connectivity. So, IP addressing are hierarchical with network, subnetwork, and network host portions. An IP address can represent a complete network, a specific host, or the broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The IPv4 host can communicate one of three different ways. It is the unicast, broadcast, and the multicast. Also, blocks of addresses that are used in networks that require limited or no internet access are called private addresses. Then there are the three types of IPv6 addresses: the unicast, multicast, and anacast. An IPv6 link local address enables a device to communicate with other IPv6 enables devices on the same link and only on that link subnet. Packets with a source of destination link local address can not be routed beyond the link from which the packet originated. After it is implemented, an IP network needs to be tested to verify its connectivity and operational performance. So, this is the summary of Chapter 7. Thank you for watching my vlog. So, see you in my next vlog, guys. Bye!